I'll paste in the chat and as soon as it goes live here. Alrighty, hey everybody, welcome to the Growing with Fishes podcast, episode 177, and with our guest Harvey Smith.
Harley, like the motorcycle.
Harley Smith, sorry.
Like the motorcycle.
Thanks a lot for joining us.
Yeah, you're welcome. It's a pleasure to be here.
Welcome to the show.
Thanks.
We also have Roger.
How y'all doing this evening? Good to be here tonight. Getting cold everywhere, isn't it? I'll tell you what.
Absolutely, yeah. So thanks a lot for joining us. And I'm your host, Steve. So thanks a lot for joining us, Harley. You have one of the most best educators in the cannabis field, especially in regards to science. You have some of the best courses out there, and I've had a chance to sit in on a couple of your different seminars and a couple of different shows that we've both been speaking at. And you've really been one of the most knowledgeable people I've had the pleasure of listening to in our field. And there aren't a lot of people that really go out there and put out a lot of really detailed stuff, but also well-researched stuff as well. And I really wanted to have you on for a while, and really excited to have you on this episode and to have you come on and share your knowledge. So thanks a lot for joining us.
Oh, you're very welcome. Glad to be here. Glad to share. That's what it's all about. You know, can't just keep it all in your head. Got to give it away. So make the way for the next generation.
Yeah, you fit right in with us, and that's for sure.
Absolutely. So tell us a little about how you got started in the cannabis industry, and then doing all the soil science and botany, and what got you into the pathway that you live now.
Okay. Yeah, I'll tell you my story. It started 25 years ago. I was a video producer back then, doing videos on science and on technology. I was contracted by a company in Michigan, fertilizer company, to produce a video on introduction to hydroponics for them to with a workbook for schools, because schools were getting interested in hydroponics back then. So I came in, not knowing much about hydroponics, did the interviews, did the research, wrote the scripts, talked to NASA scientists, talked to professional hydroponic growers, talked to some of the experts around the world, and put together the videos. Well, that one thing led to another. They wanted to do a series. That series turned into a whole new profession. They offered me a job doing marketing to schools for hydroponics all across the United States. So I started setting up hydroponics labs and aquaponics labs too, by the way, all over the United States. And I was doing professional development workshops for agriculture teachers. So that's how it started. I was in it to use hydroponics to teach plant science, a more hands-on way for students to learn about the needs of the plant and plant nutrition. And later on, along the way, I was invited to go to the Netherlands to interview some growers over there, visit the schools in the Netherlands that were teaching hydroponics. And it was like walking into the future on a time machine. They're so far ahead of us. They're 20 years ahead of us in plant nutrition and horticulture. And they were doing works with organic biostimulants back in 2001. And I was inspired. And so I started doing a lot more research, diving in, trying to solve some of the mysteries of nature, how to improve the uptake of water and nutrients, how to improve the plant's natural resistance to pest and disease, how to improve the nutritional value of food, the medicinal value of medicines, using biostimulants. And I cracked some of the codes. I solved some mysteries and got the white jacket. So that's my story. I kind of came in the back door. You know, I wasn't a cannabis grower in the closet and then working my way up, I came in through the back door of education. So it's always been near and dear to my heart to stay close to the science and apply it in an intelligent way and work with nature, because nature has all the answers if you know where to look.
So tell us more about biostimulants. A lot of people aren't familiar with the concept.
Okay, well, you're aware of the plants need 17 essential elements to grow and reproduce. That's the basis of hydroponics or soil, or however you're growing. They need those essential elements. But organic biostimulants aid with the uptake of water and nutrients. And the more efficiently plants take up water and minerals, the more chemical reactions they can do, the higher the bricks, the higher the sugar content in the sap. And that's our goal. If you can grow such healthy plants that the bricks is at 12% or higher, the organic gardeners at least tell me sucking insects won't even recognize the plant as food. It turns out though, if you do that, if you can grow those really healthy, vigorous plants, they're not only more resistant to pest and disease, they're going to be higher yield and higher quality in the end. So that was the key, was to, so I did experiments with all the minerals and hydroponics in the right balance, but then by adding a small amount of biostimulants, I was able to notice that all of the essential elements build up to higher levels in the leaf than the control. So anyway, what biostimulants are, I'll give you a few examples. Kelp extracts, that's a biostimulant. It's high in different growth hormones, natural hormones, beneficial trace elements from the seed. Humic acid, fulvic acid, they aid with the uptake of, they work synergistically with the kelp, aid with the uptake of nutrients, especially the trace elements, iron, copper, manganese, zinc. They turn on enzymes in the plant. If you turn on, Steve, you turn on one enzyme in a plant, that one molecule, if it's turned on by a cofactor, could do over 1,000 chemical reactions per second inside the cell. So very, very small amount of increased uptake of trace elements can have a dramatic effect on the plant, more so than just giving them the nutrients. We want to get them into the plant where it can do the most good. So those are three big ones. Amino acids too, which are an area that really got me the white jacket when I cracked the code of glutamic acid and glycine, and how they stimulate root cells to open calcium ion channels. So the plants take up more calcium, thousands times more than simple osmosis. And by the way, calcium is king. So if we can talk more about that tonight, I think it'll enlighten some of your viewers.
Sure. So why don't you touch on that? So one of your most popular videos is chelating calcium. So tell us more on that, because that was a whole new concept to me when I first had heard it through you.
Okay. Thank you. I mean, I kind of opened the door for that, but one of my favorite subjects. But remember I told you I went to the Netherlands in 2001? Well, back in the year 2000, the Dutch government made all synthetic fungicides illegal on food crops, because at least at that time, I think now too, all the known fungicides had at least the potential for negative side effects on human beings. So they stopped using fungicides in the hoop houses in Netherlands. So within that first year, the growers were losing 40% of the crop to powdery mildew, to gray mold, other fungi, because they couldn't use fungicides, and they were growing in relatively high humidity environment in the hoop houses. Well, anyway, they had to do something. So they started experimenting. They brought in some organic biostimulant products that were being made in Germany at the time. They were using them in pollution control to unlock nutrients in the soil so the plants could take them up so they could use less fertilizers. Well, anyway, I went to the Netherlands. They went from losing 40% of the crop to losing 0 to fungi. They got a 10% increase in yield over any past year, and they were first in the line for bricks, for sugar content in the fruit. So they were literally growing the best of the best and increasing yields too. So I said, well, we need this in the United States. What's in it? How does it work? They wouldn't tell me. They said, oh, that's proprietary. It took us 10 years of research. By the way, nature's been doing it without our help for millions of years, okay? But they wouldn't tell me. So I saw it with my eyes. I knew it was possible. So I went back, started doing research, started looking for clues. They end up burning the midnight oil, literally. It took me about 4 or 5 years. And then finally I got hold of I learned a lot along the way, by the way, but I got hold of a amino acid blend from a vitamin manufacturer out east. He asked me to do some trials for him, some tests. So I did some experiments and I cracked it. It took me a little while, but I cracked the code. Amino acids were the key. 2 of the amino acids, glutamic acid and glycine, used at the right levels at the root zone, literally stimulate root cells to open up calcium ion channels. So the plant takes up more calcium. Plant takes up more calcium ions. It reacts with pectic acid to make pectin. That's the glue that glues the cell walls together. Now, when a powdery mildew spore lands on a leaf, it doesn't germinate in the surface water. I mean, you can rinse it right off. What happens, it sends the germination tube down from the spore to get to the water in the interstitial space, becomes systemic in the tissue, then it spreads. But if you get more calcium uptake, instead of water in the interstitial space, you have pectin, calcium pectate. So by the time that the mold spore is able to get to the water, penetrate the stronger cell walls, it dries up and dies. So it's not killing the fungus. It's not a fungicide. It's preventing the fungus from getting established and spreading. Okay, so that's good. And nature's been doing that. Microorganisms in the root zone make digestive enzymes. One of those enzymes is called a protease. It breaks down proteins into amino acids right on the surface of the roots. So nature's been doing that because calcium gets locked up in the soil really easily. So nature has a way of improving the uptake of calcium by the plant. Now, as a side effect, the plant will build stronger, thicker stems, thicker cell walls. That's the vascular system. So the plant's able to take up and distribute water and all the other essential elements more efficiently. And what we said, remember, the more efficiently plants take up water and minerals, the more chemical reactions they can do, the higher the bricks. They were first in the line for bricks in their tests. So they eliminated the powdery mildew because they had stronger cell walls, and they increased the bricks because they had better uptake of nutrients. After I cracked the code, though, I was doing leaf analysis in the lab. Every single essential element build up to higher levels in the control, nutrient dense, lots of minerals to that, including iron and copper and manganese and zinc that turn on enzymes for increasing the yield. So that was the breakthrough. And by the way, I confirmed it. About 5 years later, I went back to the Netherlands on another trip to look at biofilters that they were experimenting with back then. And I told them about the experiments I was doing with the 7 primary amino acid chelators. And they said, Harley, you know more about our products than we do. And they started pumping me for information. Of course, I said, that's proprietary. That took me 5 years to figure this out. But I said, I'll tell you 2. And I said, so I asked them, is it the calcium? And they said, it's the calcium. It's not giving it more CalMag. It's not adding more calcium. It's making the calcium available to the plant thousands of times more efficiently. And nature's doing it without our help for millions of years. So I guess that's the long, short story.
Because we know the plant only uptakes what it wants anyway, and that people keep trying to force extra things on it that aren't necessary. We touched on that before the show. You only need what's necessary, and that's where the science comes into it. So nice, yeah.
It is. If you just add more calcium, calcium locks up really easily. It locks up with phosphates and makes calcium phosphate. That's what your bones are made out of. 95% water insoluble. That means it's unavailable to the plant. I'll tell you what the clue was, though, since we're still talking about this. At the time I was growing in Michigan, I had hard water. It's really high in calcium carbonate, magnesium carbonate. The pH is high and it was buffered. I had to add 10 times more phosphoric acid to lower the pH than I would in the city, with the city water. But I could literally see it when I added the pH down in hydroponics. I could see crystals of calcium phosphate forming, sparkling in the water, fall out of solution, precipitate out like snowflakes, and cause huge problems with lime scale. But when I added the amino acid blend that I was experimenting with, first thing I noticed, no more lime scale. At the end of the grow, instead of I couldn't even scrape off the scale, I literally took a paper towel, wiped a little algae film out of the reservoir, rinsed it with the hose, it was clean. So I thought, wait a minute, where did all that calcium go? Oh, that's a clue. It went into the plant. So I got to narrow my search between the amino acids and calcium, and found the research from different universities around the world that were experimenting with patch clamp technology and voltage gated ion channels. So the answer was there. So that was the clue. So it isn't just giving them more calcium, it's keeping it soluble and also stimulating the uptake. And that's where you have super strong, healthy plants.
So how does silica play into that? I've often, when I originally worked with the aquaponics source, we actually did a study with tomatoes to try and figure out why they were off flavor-wise, and we weren't really looking at flavonoids or terpenes yet, in the fruit tissue, but we were looking at nutrient density, and what was different was the chloride and the silica, and that really got us into testing silica, and then we noticed that it had increased disease resistance and caused all these other benefits when we were testing it. So tell us about silica and how that works.
Yeah, silica works together with calcium. Calcium makes the glue that glues the cell walls together. Calcium, magnesium, pectate. Well, silicon works kind of like rebar. It reinforces the strengthening of the cells. Now, so it helps with a physical barrier, sort of like an insurance policy, an additional level of protection against the fungi, against the powdery mildew. The cucumber growers, the first thing they do when they bring in their water source is they add silica to the water, potassium silicate, to help protect against powdery mildew, because the cucumbers are very susceptible to powdery mildew. So also, if the plant is under attack, say by powdery mildew or mold at the leaves, the plant will mobilize silica to the point of infection, crystallize the cells around the infection point, and help prevent the disease from spreading. So you have a little bit of a improved physical barrier, but then you have a backup of the silica that will go right to where it's needed, when it's needed, if and when it's needed. So that's
awesome, because here in Carolina, we grew cucumbers, and I got into the hydroponic business to grow derator cucumbers, and the guy always had the powdery mildew problems, and I guarantee you he probably was not using silica. And so I'm curious. So now can't wait to call him tomorrow, because even though we've been on silica for a while now, thanks to you, partially, and amino acids too. I wanted to say that earlier. That's how I first heard about you, was you hit a nerve with people and they were discussing your amino acids. So anyway, I'll give it back to you, but that is a big, I concur that is a big problem, and possibly a good solution in the Southeast and all for cucumber growers. And that's something to
it's critical when you grow squash. If you don't do it, especially in an aquaponic greenhouse with the higher humidity, you're just gonna get eaten alive.
I know most people don't want to grow squash in hydroponic greenhouses because of the bugs. The bugs love squash.
Oh yeah, I've seen some squash beetles, some cucumber beetles, I guess they call them, out here in Oregon in the fields this year. Yeah, so yeah, that would be synergistic, the silicon with the amino acids, with the calcium uptake. And there's, and while you're at it, remember, calcium is passive. It's only taken up in the transpiration stream. So if you have high humidity, the plant's not transpiring as much water because the air is wetter. And so you can get calcium deficiency, even if you have plenty of calcium in the root zone. But the good news was, though, when they used the amino acids, even in the hoop houses with high humidity, they still reduced losses to powdery mildew to 0 in the Netherlands. So that was a breakthrough. And again, it's just a secret of nature. It wasn't really, I mean, it's not forcing the plant to take up calcium. It's not force feeding them. It's just making the calcium more available and helping the plant take up what they really need to potentially reach their genetic potential. I'll tell you one more thing about the calcium though. Remember, we got the calcium uptake, strengthens the cell walls, prevents the powdery mildew, but the extra calcium that the plant, ions that the plant takes up, they literally, the plant will pump those calcium ions into a vacuole, into the storage container inside the cell, the extra calcium ions. Now, if there's a hot spot in your greenhouse, let's say there's one area that you got just a little bit, an outbreak of powdery mildew, the plant itself, the plant senses the chitin in the cell wall of the fungus. Plants don't have chitin. They have cellulose. The plant knows it's under attack. So the plant itself sends a signal molecule from the surface of the cell to the vacuole to open calcium ion channels in the vacuole. And thousands or millions of calcium ions flow into the cytoplasm, activates a series of enzymes that produce what's called an oxidative burst. And that's the plant's first line of defense against the fungi. So it's not just a physically stronger plant, there's actually a reserve of secondary messenger, calcium as a secondary messenger if it's under attack.
And you're saying that's like with the application of the amino acids, it does that.
Well, there's the amino acids are, the signal molecule literally opens up calcium ion channels inside the cell. The amino acids stimulate root cells to open calcium ion channels so that it's taken up, but it's still taken up passively in the transpiration stream, but at least there's thousands of more ions that are taken up instead of one at a time. So it's still, even with high humidity, it was effective, but there was a secondary benefit that I actually found out about later in my research.
That's really interesting. So,
Yeah.
so on that note, have you, because you touched on it earlier about the role in disease, have you seen other diseases come? Like, what new diseases have you seen this year in particular? I know I've seen septoria more places than I've ever seen it before. I've only ever seen it once, but I've seen it all over the place, and other diseases. What have you seen a lot this year that maybe was new, and then new viruses? What have you seen this year and dealt with talking to people?
Yeah, there's that dudding virus out there. It's a hop virus that is latent, so it may not even show up until later, and it can be spread, genetically through clones even, and seeds. But so I've seen some of that. There isn't really a way to treat it though, or kill the virus. It's hard to treat viruses anyway. But what you can do is through tissue culture, you can take a little bit of the tissue that is not attached to the vascular system yet, because the virus is spread from the older growth to the new growth. So if it's at the very growing tips, take a little tissue, you can grow a new clones and new mothers that are virus free. And there's another extra step in there that I'm hearing about where they'll do a chill in that too, because that slows down the virus in the process. So that's one that I've seen that can be a big problem out there. I've seen some fusarium problems from people that have been reusing soil for too long, and it's becoming really acidic, too acidic, too much manganese. So I've seen more fusarium than I have in the past. Saw some cucumber beetles, but not a big deal. I mean, yeah, they eat the leaves, but they're not going to kill or hurt a plant much. And the caterpillars. I've seen that, and those are really, they're so small, and they get in the buds, and then they'll cause some damage, and then as a secondary infection, you get the botrytis, the bud rot, later on. So I've seen some of that, and I know that a lot of the growers do some pre-treatments with natural caterpillar, the BT with the K, BTK, as a preventative early on. But those that didn't do it, I've seen them lose quite a bit this year to the caterpillars. I guess that's the main things I've seen. And I didn't see a lot of that in the past, in the years before, because I was in Michigan for years and it was all indoor growing. So you don't see that.
Yeah. Yeah. No,
now I'm learning about soil-borne pests and diseases. Oh, great. But there's an answer to that too. There's microorganisms in the soil that colonize the roots and make antifungal agents to protect their food source.
I think one of our other guests knows all about that. Hey there, Chris.
Oh yeah.
Hey, Chris. How you doing, buddy?
Hear me?
There we go.
I see Marty.
How's it going, guys?
Hey, buddy.
Chris.
Nice to
How's
see
it
you.
going? How's Thailand?
Thailand's good. I think I'm ready to be home, though.
Well,
Yeah, it was a sweet
Leave
time.
that alone.
Leave that. So Marty must be really big on plant growth promoting rhizobacteria and mycorrhizal fungi.
No, Chris Trumpus.
I mean, Chris. Oh, okay. Chris is.
Natural farming, Korean natural.
I mean, I'm
farming.
not opposed to him, but he was referring to Chris. That's for sure.
Yeah.
Yeah, that's really the new frontier. I'm so lucky. I get to work with a microbiologist out east who has 1,200 pure strains of plant growth promoting rhizobacteria from around the world. Yeah. So
That's
I've
insane.
been quite an education from what I call a real microbiologist.
Now, do they have any kind of publicly available education, or is that strictly?
Yeah, once again, it's proprietary.
Oh,
but
sure.
that's what I'll do. I learn from him, and then I go ahead and spread the word. One of the classes I do in the Master Grower Short Course is all on microbial inoculants and compost tea. So I really get into the superstars of the rhizosphere and how they work together, how to build a team of microbes that feed each other while they're feeding the plant. So I've learned from him.
Yeah.
And some of it I share, but I can't share specific recipes or anything like that.
That's the difficulty with the university system. The grower doesn't really have access to that without a pretty big price tag.
Right, and the universities are also doing controlled studies, and they can only have one variable at a time, so they focus on one or two microbes at a time. It's synergistic.
Like,
it's not one. It's not one microbe that does the job. It's the combination, and it's really hard to do scientific trials with combinations or microbial blends.
I'm
we
glad
don't
you
have the
pointed that
computing
out.
power.
Yeah, I'm glad you pointed that out because that's the truth. They got so many benchmarks and they have to go through trials for so long. It's a snail's pace. And I'm sorry, Chris, didn't mean to interrupt you.
No, you're fine.
Yeah, the microbiologist that I call him Bacillus Bob, by the way, his nickname, but he's been with microbiology and agriculture for over 30 years. So he's been able to do not only isolate and culture these microbes, but he's able to find out, okay, one at a time, which ones are best at solubilizing phosphorus, which are best at fixing nitrogen, which are prolific at making enzymes, or which are prolific at making IAA, indolacetic acid, which ones make, so he can do, so he's been able to take 30 years, one at a time, to find the microbes that have superior characteristics. And then the real work, though, was combining them in a way that they complement each other instead of compete with each other. And that's what really took the long, so it's still been a long process. It's not something that just came out 2 or 3 years ago. It's been a journey for the microbes.
Now, is that something that people can get their hands on, or is it something that's coming out in the future? Or?
But we have them. I have a blend that that he developed for us at calixcpn.com. You can go there and look at, they have an azose, which is nitrogen fixer. They have a starter blend, which I really like, to inoculate the roots, because it has the phosphorus solubilizers. Remember, phosphorus is the energy element. It energizes rooting for better root strike and establishment. So it's one of the benefits of mycorrhizal fungi. It unlocks phosphorus from the soil, and from the organic matter feeds it to the plant. But then there's phosphorus solubilizing bacteria that work synergistically with the fungi. They'll swim in the soil solution to places where the fungi can't reach, unlock phosphorus, feed it to the fungi. And then the fungi feeds it to the plant. So, and there's also microbes that they found that have genetically superior characteristics to make rooting hormones, make auxin, literally right on the roots. One of the amino acids is tryptophan. There are some microorganisms like Bacillus licheniformis is a good example. It'll snip off a little nitrogen from the tryptophan. It literally changes it into IAA, indolacetic acid, a rooting hormone, right on the surface of the roots. And I thought, when I heard about that, I thought, well, why? What's the competitive advantage for a microbe to make rooting hormone? Well, the answer is, at least in what I think, is every cell, every living creature on this planet, the genetic code says the same thing: be fruitful and multiply. So if as the roots grow, the microbe colonies grow with them. So if the microorganisms stimulate more root production, then there's more surface area for the microbe to colonize. And because of that, there's more of a sponge of roots to take up water and nutrients and make more sugars because of that. And then some of the excess sugars are leaked from the roots to feed the microbes. So it was in the microbes' interest to stimulate the plant to make more roots. And so by producing those auxins, it's accelerating the process of life.
So we were talking a little bit before, or not before, when we were talking about possible topics for the show. One of the ones I was dying to ask you about was about molybdenum, and how molybdenum plays a role in both for converting nitrate as well as for anthocyanin. And you actually learned a bunch of stuff about it, and you were stuff that I didn't even know about it on how. So I'd love to hear more about that.
Okay, sure. Molybdenum is an essential element for plants, but it only needs a very small amount, a fraction of a part per million. In a hydroponic nutrient, it might be 0.005 parts per million. 0.01 parts per million at the most.
It's like half a quarter of a teaspoon for 300 gallons.
There you go. You can make it at home yourself. But it's a very like half an aspirin. It's a very small amount. But it's essential. If the plant doesn't have it, the plant can't properly assimilate nitrogen, because molybdenum activates an enzyme called nitrate reductase. Now, the plant takes up nitrogen through the roots. It sends it up to the leaves, to the chloroplast. It takes a lot of energy to do this. And then through an enzyme, it breaks, the plant changes nitrate into nitrite, and some other enzymes change nitrite into amino acid, ammonium. Then the ammonium is changed into amino acids, and then the amino acids are used to build proteins and enzymes and chlorophyll and everything else that nitrogen is needed for. But that first step in assimilating nitrate is turned on, that enzyme is turned on by molybdenum. So if you have a molybdenum deficiency, it'll look like a nitrogen deficiency because the plant can't use the nitrates. I do want to say one thing about nitrate nitrogen though, is it takes a lot of energy from the plant to assimilate the nitrates. They have to reduce those nitrates. It takes energy at every step. About 20 to 30% of the energy of photosynthesis goes to assimilate nitrates. And nitrate nitrogen is a luxury element. The plant, this is one of them that the plant will assimilate whether it needs it or not. You give it more nitrates, it'll assimilate those nitrates. You give it even more, it'll stimulate the plant to make the enzymes to assimilate even more nitrates. It's a luxury element, but it burns up the energy of photosynthesis in the process. So if you overdo it with nitrate nitrogen, you'll get big top growth, but it will restrict the root growth because it's burning up. There's no extra sugars that it can ship to the roots. Also, if you overdo it with nitrate nitrogen, you get big cells, thin cell walls. The plant's more susceptible to powdery mildew. It's an easy meal for sucking insects. The Brix goes down. So if I want
in cannabis and hemp, it's probably not the preferred food. Ammonium is.
Ammonium nitrogen is assimilated directly in the roots. It's not assimilated in the chloroplast like the nitrates are. But here's the bad side there, though.
It's interesting that you talk about the nitrogen cycle going to nitrate and then back to ammonium.
Right.
There's some research out of Japan and Spain where they show that the archaea, sorry, I'm probably saying that wrong,
That's
is
right.
taking atmospheric nitrogen and rain-borne nitrogen and actually converting it to a form of ammonia. And then when combined with water, dew point in the morning or a rain, right on the leaf surface. And then it drips ammonium because the ammonia, when combined with water, creates an ammonium. And it drips it to the root zone. And then in the root zone, there's a process that a plant can do called nitrification inhibiting. What's it called? BNI.
Well, it's nitrification.
Denitrification or nitrification?
There's denitrification and there's nitrification.
No, it's not either of those.
Microbes that you're really familiar with in aquaponics that change, some of them change ammonium to nitrite, others, nitrosomonas and nitrobacter. And nitrobacter changes the nitrite to nitrate, and the plant takes up the nitrate and reverses the cycle. So there's denitrifiers too, and that's why I never use sugars in hydroponics, because in hydroponics,
the plant's root zone can inhibit nitrification. So basically, it drops itself ammonium from its leaf surface, where the archaea is specific archaea. So they have no nitrifying archaea on specific plants, literally just converting to ammonia and then ammonium. And then in the root zone, they can inhibit the nitrification process to keep it at ammonia. And they're basically, with their drip line, feeding themselves ammonia and never actually going to nitrate. Cannabis, hemp, many tree crops are able to basically customize their nitrification or their nitrogen cycle for their preferred feeding just by the relationships they create both on their leaf surface and in their root zone. You know, with our feeding programs and what we can buy or produce, sometimes I think we're just misfeeding or kind of taking away, like you said, the preference and giving them such an energy drain to take these high amounts of nitrates and try and you know, make fruit with it. Where if we have diverse microbial life, like you said, the incredible complexity of the interconnectivity of microbes and how they work together to feed the plant and to convert nutrients. I think nature's a little bit bigger than we're giving it credit for almost all the time.
Yeah, some of those microorganisms in the root zone are 95% efficient for recycling and making nitrogen available to the plant real time, just in time manufacturing. If the microbes over make nitrates are negatively charged ions. They're very water soluble, but you get one rain, it'll wash away the nitrates from the root zone. It's unavailable to the plant. So yeah, it's kind of a self-regulating system at the root zone. Now the microbes themselves prefer the ammonium form of nitrogen. They're more, not the nitrate, but the plant uses both ammonium and nitrogen. But remember, if you overdo it with ammonium, if the microbes aren't there and they're changing it to nitrate, the ammonium is toxic to plants quite quickly because it's taken up directly in the roots, but it has to be changed into amino acids right away because it can't be stored in the vacuoles for later like nitrates can. So they have to take some of the stored sugars and change those in, add it to the ammonium to make amino acids. And then of course the amino acids make the proteins and enzymes and so forth. So if you overdo it with ammonium nitrogen for the plant, that can be toxic too. You get rank growth where it's soft growth, and that's not healthy either. And nature does it both forms of nitrogen, the nitrate and the ammonium, and the microbes help keep everything in balance.
So I was real interested, you were talking a little bit about how molybdenum toxicity increases anthocyanin production, or how does the molybdenum play into the anthocyanin?
Okay, yeah, if in nature it's rare, almost never see a molybdenum toxicity. That's one of those, you know, it's an essential element. It only needs a very small amount, but most trace elements, say copper, you know, there's a narrow window between deficiency and toxicity. Well, molybdenum, the plants have, I don't know why, but they can assimilate high levels of molybdenum without hurting the plant. I didn't even know until today what the symptoms of molybdenum toxicity were. I would never see it in any of the growing in regular agricultural programs. But if you add high levels artificially, more than likely, high levels of molybdenum, the plant will send that extra molybdenum into the vacuole, and then it will complex with the anthocyanins. And anthocyanins are the purple pigments. So you might say detoxifies it, it complexes them so that it doesn't interfere with other processes. So that's why you start to see more of the purple pigments with a molybdenum toxicity. The molybdenum doesn't make the anthocyanins. The anthocyanins just complex with the molybdenum under high molybdenum conditions. Now, I want to say something about the anthocyanins, though. The purple pigments. One of the ways to increase the colors and aromas is in hydroponics, especially, is to create what I call healthy stress on the plant. If the plant is experiencing some stress, and in hydroponics we do it through a salt stress by adding more nutrients, so it's harder for the plant to take up water, increasing the EC. Well, under stress, the plants will make antioxidants to protect themselves from the stress. And some of those antioxidants are the flavonoids and the anthocyanins. So in hydroponics, if I want to bring out more colors and more terpenes, I slowly increase the amount of mineral salts at the roots, little by little. The plant will balance it by sending more sugars and amino acids to the root so it can keep taking up water, but it creates just enough stress so you get more color, more aromas, and more flavors. I did one controlled experiment where I did 3 levels. I tested 2 hydroponic nutrients side by side. I did a half strength nutrient, full strength nutrient, and a 1.5 high strength nutrient. Same strains. The ones with the high ECs had, without a question, the best color, aroma, and flavor. The other side to that is light. The blue end of the spectrum, from ultraviolet A into the blues, stimulate the precursor molecules to the anthocyanins in the plants. So knowing this, doing my experiments with light and with minerals and with stress, I was able to bring those things out. So back in the old days, not that long ago, medicinal days in Michigan, we were allowed at that time to sell our overage to the dispensaries. And it was really high. We were making a lot of money. We were getting some bucks for that really good medicine. Well, anyway, after a while, the prices started going down for the growers. There's more supply and demand, and they started to go in with your sample. They say, okay, they take down the top shelf. We pay so much per gram. They take the bottom shelf. We pay so much per gram for this. Where does yours fit in? Well, I guess it's somewhere in between there. So they'd always get you lower and lower prices. So I said, well, wait a minute, 2 can play at this game. So I decided to grow a purple strain with high anthocyanins. So I did my test, I did my work with the EC step by step. I switched my bulbs, added more blue the last week or so. I mean, the purple colors were off the chart. The aromas were off the chart. I brought that into dispensaries. I said, okay, here's my sample. Do you have any purple strains? Oh yeah, we have a couple. Come on, bring them down. I did a side-by-side test. It wasn't even close. I opened it up. The aroma was in your face, strong with the terpenes. And I said, well, where does it fit in? They said, you get the highest price. And I got the highest price every time. Now, I'm not saying that was the best. I'm not going to claim that. All I'm saying is had the darkest colors, the richest aromas, strongest flavors. I don't think it was the best. I like some of those more subtle overtones, but in this case, it was bag appeal, and I used the science to help meet the market demand and not go out of business in those days. So that's just an example. So it's more than just stress, but healthy stress and light manipulation can bring out more of the anthocyanins, more than overdosing with toxic levels of molybdenum. Better than that.
Now you touched on lighting. Do you want to touch on why it's important to have or not have certain types of lighting if you're growing CBD? So that was one of the things I think you touched on the last time I heard you talk.
Yeah, that was probably at the conference in Oklahoma. I actually got to do a presentation on plant nutrition for cannabis. The very first time in 25 years I did a cannabis specific lecture, but in Oklahoma, go figure. Anyway, it was, okay, what was it now on the light? What was the question again?
On CBD and what
CBD.
how lighting affects
Light,
CBD.
yeah. Okay, I saw some research papers on lighting where they were experimenting with UVA and UVB for medicinal herbs. This was university studies. And it wasn't just cannabis, it was other medicinal herbs too, for the secondary metabolite production. They found that UVB, that's the UV light that gives you a suntan, UVB stimulates the production of THC, but it suppresses the production of CBDs. So That's one of the things I'm really careful of out here now with the high CBD strains growing outdoors in sunlight, high light, lots of UV, UVB, is how do we keep it from coming in hot? So we take extra precautions to keep the stress off the plant, to manage the nitrogen very carefully, and not over, don't create additional stressors. Don't over fertilize with phosphorus. So we can kind of compensate for it. Oh, by the way, UVA stimulates the plant to repair the cellular damage from UVB. So nature, again, kind of has a way of fixing the problem that's being created. So it's really a combination. It's the percentages. And there's much higher UVB than there are UVA than there is UVB outdoors. So it helps remediate it.
So one of the other things I learned in your talk too is how manganese affects THC expression. Do you want to touch on that? And then if you had a lot of manganese, does that inhibit THC expression, or how does that work if you had too much?
Yeah, if you remember, there's trace elements. There's a narrow window between too little and too much. And if you go too much, it can a lot of times have the opposite effect of what you're looking for. So anyway, a quick story here. I was working with a commercial grower here in Southern Oregon, indoors, and they had one room, a bloom room, that was underperforming. At the transition period, that 2-week period between grow and bloom, and they moved it from the grow room into the bloom room, the plants were stalling. There were some symptoms on the leaves of deficiency. Of course, later on it recovered, but it never performed very well. So they called me in to help them as a consultant. So I have that lab with an ICP spectrometer. So what I did, I cheated a little bit. I took a leaf sample that had the symptoms. I took leaf samples without the symptoms, ran them side by side, and I found out that the ones that were unhealthy had 1/3 the manganese of the healthy leaf. So the question is, why? We're giving them manganese in the nutrient, why isn't it taking it up? So I had to do a little detective work. First thing was, what was the difference between the grow and bloom? They went from the grow room when there was lots of blue. Blue stimulates the stomata to open. Green stimulates the stomata to close. So the stomata were more open to take up CO2. So when they've switched to reducing the blue and adding more reds, the plant wasn't stimulated to open the stomata. At the same time in that room, they went from low CO2 to high CO2. High CO2, the plant adapts by closing the stomata. So it started to close the stomata. It didn't have the extra blue light to open it that it was used to, that it had adapted to. Too many changes too soon. So I had them add 20% more blue to that room during transition. I had them ramp up the CO2 and, of course, treat the symptoms. We did an amino acid chelated manganese. Did that as a foliar spray a couple times. End of the story. They went from having an underperforming room to the best room ever for production, and they turned around and won first place at the Oregon Grow Classic for THC content and for first place for terpene production in that particular contest. They all had the same genetics. So I went back and I said, oh man, I've been wanting to experiment with manganese. Manganese actually turns on genetic pathways in the plant to make the cannabinoids. It's a cofactor, magnesium and manganese. So by solving the deficiency problem, we brought the other manganese up to the high end of sufficiency, and the plant responded. And I found out from that too, which we didn't know, it's not in the books, it's not in the literature, that there's a feedback loop. Not only does the plant make more of the cannabinoids, but it stimulates the plant to make more of the precursor molecules and the terpenes. Because the terpenes branch off to make the cannabinoids later on at the end of their life. So I got to discover something by accident with getting the ideal levels of manganese. But you don't want to overdo it, because then it becomes toxic to the plant. They'll compete with iron, and you really need iron and manganese at ideal levels to have the cannabinoid profile that the plant wants to make. It's not just manganese. There's a lot more going on. It's like it's not one microorganism. It's a combination of things. So people don't, the takeaway from here isn't, oh, just give them a bunch of manganese. No, that's not the answer. But manganese is part of the process.
So you're one of the few people I'm aware of that can actually speak on vitamin B and how that helps plants. Do you want to touch on that? I know that's one of the products that you guys have through your company, and I've actually regularly purchased that for quite a few years.
Yeah, B vitamins are controversial. It's a controversial subject. Adding B1, usually it's a combination of Bs, B1, B3, B6, maybe B5, maybe a couple more. They work synergistically better than just B1 by itself. But we used to think that B1 prevented transplant shock and stimulated root growth. Not true. That's not how it works. Now, if you were given your B vitamin blend and you looked at those microscopic root hairs under a microscope, yeah, they're a little bit thicker, but not a lot more roots. If you did an analysis, you'd see that there are B vitamin derivatives in the plant. So the plant does take them up and uses them. But what it really does, the biggest thing, is it activates enzymes for cellular metabolism of the microorganisms. And so as the microorganisms are growing, as they start vibrating with energy, they divide. As the microbes are actively dividing, that's when they make the digestive enzymes, the rooting hormones, and the chelators to help with the uptake of iron, to activate enzymes. So there's a secondary effect there. Also, for a direct effect, B1 at high level, relatively high level, stimulates the immune system of the plant. It's called this SIR, the systemic induced response of the plant itself. There was a lot of work done in Korea on this. So it sensitizes the plant. It puts the plant on high alert. So if the plant is under attack, say by a root pathogen, or if it comes, the plant's own natural immune system responds very quickly. But if everything's perfect, you're not going to see any difference whatsoever. But here's the thing, no matter how careful you are when you transplant, you're probably going to break some of the microscopic root hairs because they're fragile, and that opens the plant up to infection. So if you stimulate the systemic induced response before transplant, the plants will respond more quickly and to fight off any pest and disease. That's why gardeners for many years thought that it helped prevent transplant shock. So, but technically speaking, it doesn't. Technically speaking, it stimulates the plant's immune system, and if everything else is perfect, you won't see any difference. And well, you will see difference if you use kelp and humic acid. If you do 5 parts humic acid to 2 parts kelp, you'll stimulate more lateral root growth and more root mass. It'll be obvious, percentages, 20% more roots. If you give it just a little bit of extra phosphorus at the right time, or you have phosphorus solubilizing bacteria, that will activate root growth for more root mass. But the B vitamins themselves don't. Okay, now the kelp though does have B vitamins in it. Kelp does have amino acids in it. Kelp has auxins and cytokinins in it. So there's more, again, just with the kelp itself, it's not just one thing, it's a combination. Combine it with humic acid, that 5:2 ratio, it amplifies the effect. It stimulates the uptake of iron and some of the trace elements that activate those enzymes for cellular metabolism, makes more root cells. So, that's part of the reason why there's controversy. Because if you just take B1 by itself and you test that in the lab, you may or may not see a positive response on rooting. But in nature, B vitamin is part of the solution to protect the plant and to stimulate metabolism of the microorganisms in the root zone.
We had a couple of questions from chat. It says, can you ask Harley about the connection between nitrogen and calcium uptake?
Calcium and nitrogen uptake. Oh, that's interesting. Amino acids for, okay, well, amino acids have nitrogen in them. If you looked at the guaranteed analysis, you'll see a pretty high level of nitrogen. Oh, am I going to burn my plant? Oh, am I going to inhibit flowering? It's not nitrate. It's not ammonium. It's part of the amino acid molecule. It has an amino part, that's ammonium ion. It has an acid part, that's carboxylic acid. And it has side chains along with it. So the very little, if any, of the amino acids are actually taken up by the plant. What it does is it stimulates the uptake of the nutrients. Now, as the microorganisms make amino acids, so they can use it as a nitrogen source for them. But we already talked about that. There's going to be a whole nitrogen cycle involved before that's in a form that slowly available nitrogen for the plant. So the amino acids are not a nitrogen fertilizer. They stimulate the uptake of nutrients such as calcium. And we had to spend a long time with that earlier. Two of the amino acids are intermediate chelators. The acid part, carboxylic acid, when it ionizes, it forms a negative charge. So it's able to attach to mineral ions like a claw. Chela for chelate, chela means claw. So amino acids are organic molecules, complex are attached to them, hold them tightly enough so they don't get locked up. Calcium gets locked up really easily, but loosely enough so they're available to the plant on demand. And then they have secondary benefits, literally through millions of years of evolution, to improve not only keep the calcium soluble, but to stimulate the uptake of the calcium thousands of times more efficiently. So here's something else with the calcium uptake we didn't talk about last time. Plant takes up more calcium, we know, strengthens cell walls, stronger stems and leaves. It takes up and distributes the water and minerals more efficiently. The Brix goes up. But calcium also activates the enzymes that pump the auxins to the new bud development and pump the auxins for the new root development, the growth hormone. So calcium is a secondary messenger in that point too. If there's plenty of calcium to make new cells, it actually pumps the hormones that tell the plant, make more roots, make more cells. Let's build the new cell walls. Nature is beautiful, and all the way down to the microscopic level. It doesn't waste anything. So so the calcium uptake strengthens stems and leaves. The plants will make more sugars. They'll pump more growth hormones. They'll leak some of the extra sugars to the roots to feed the microorganisms, and the process of life is enhanced, not just to help the plants survive, but to help the plants thrive.
Well, what was that microbe you were talking about for the process in Korea?
Oh, that's the B1. They did scientific tests on B1 in Korea, and they found that, scientifically proved that it stimulated the systemic induced resistance of the plant, and it lasts for 10 days. One dose will stimulate that immune system for 10 days before you give it another dose.
Now, does that translate into like increased terpene expression for cannabis plants?
For the
For increasing the immune system, generally that helps increase terpene expression.
I don't know. I have to think about that one. Maybe indirectly. I'm sitting here thinking for a second, trying to put the pieces of the puzzle together in my head.
Gentlemen, I'm gonna step into a dental clinic actually, and Steve,
Sure.
but
Appreciate you.
Really cool
Hey,
hearing
Chris.
about your work, Harley. Super cool.
Chris, why don't you tell everybody what you have coming up in your next classes and stuff like that before you run?
Yeah, we're
Yeah,
quite a while here too.
What's that?
Yeah, we'll wrap up here in a second. Chris, why don't you tell everybody what your next class is?
Yeah, I'm not sure. I haven't set a schedule for 2020, but we'll do a class in Boise late spring, early summer, or and possibly a second in early fall. I'm going to be in Israel in fall 2020, and I'll be speaking at a cannabis conference in London in November. And yeah, I'll be in Australia, and looks like we're going to set up a class out there. I have to go out for a macadamia symposium, and so yeah, just kind of seeing what 2020 is going to look like. I just quit my job working with a somewhat unrelated nonprofit, but I hope to spend a little bit more time in Southeast Asia working with some of the people I was working with here this time. There's poor farmers in Myanmar, really amazing people doing amazing things and serving their communities. So I hopefully I'll be being able to give a little bit more away in the journey of all this in 2020.
Cool. Appreciate it. Well, thanks for joining us,
Yeah.
man. We'll catch you again soon. Cheers. Travel
Yeah,
safe.
totally. Have a good one.
Good
Thanks.
night, Chris. Take care.
All
And,
right. Good night.
Good night.
Right.
Thanks a lot to Harley. Why don't you tell us about your the classes and education and how people can learn more from you and you know if they've really enjoyed the episode, how they could spend more time with you.
Okay. Well, there's two ways. The one way is through npk-university.com. I do a Master Growers short course. It's a 12-week course, one night a week, for an hour lecture, and then we have live questions and answers afterwards. So that's one way to do it, to sign up for the course. The next round of classes starts on January 7th for 12 weeks. So that's one way. Try to do something for everybody there. The other way is through Calyx, that's KALIX-CPN.com. And that is kind of the commercial side of the raw that we've been talking about in the past, the individual minerals, the individual biostimulants, commercial quantities, commercial prices. But along with that, we have consultation services for commercial growers. A little pricey per hour, but we go into stuff that we wouldn't cover in the class, all the way to making your own nutrient solutions from scratch, to the part with molecular weights, vapor pressure deficit, programming dosers for, things that you would use in a commercial setting, which I wouldn't do in a typical class, in just a general class. But we fine tune it privately for your strains in your environment, and work together to develop together. Not Harley's way of doing it. Never do that. Work together to develop and improve growing strategies to meet the priorities of the grower, whether it's quality, yield, IPM, environment, whatever the priorities are. So those are the two ways: one-on-one private consultation through Calyx, or general classes and YouTube, free YouTube stuff too, through NPK University.
Awesome. Well, I really appreciate you taking the time to answer our questions tonight and educate us and share your knowledge and tell people all about how to find some proper education on cannabis. There's so many people that have classes that aren't anywhere near a tenth as in depth as yours are, and really appreciate all the wonderful education you put out there.
Well, you're welcome. It's not just cannabis, by the way. If you're growing healthy plants, you can grow the best of the best of romaine lettuce. I mean, you can get huge yields of high quality tomatoes, not the stuff that tastes like cardboard in the winter. There's a lot. You can grow herbs with 20% more aromatic oils, really high quality stuff, gourmet. So it's not just about cannabis, but cannabis is new kid on the block in some ways for research, and we need to apply this research in a intelligent, reproducible way, not just with folklore from the mountains.
Yep.
You grow food as well. You grow food as well with cannabis.
Oh
I
man.
read it on the forums.
Yeah.
Yeah.
Well, appreciate it. Thank you so much for taking the time to join us this evening.
Okay, well, good night, and invite me back sometime.
Oh yeah, anytime, man. Thanks a lot.
Harley, it was a blast to share info with you, brother. Next time.
Okay. Yeah, I'd like to learn from you too. So
Thank
see
you.
you later.
Wonderful. Cheers. Thanks a lot.
Goodbye.
And for everyone listening, you can find more information on his classes and his websites is in the description. You can just click on the links to both his next class as well as Calyx and NPK University as well. So always fun to have him on. I actually run into him pretty regularly, and actually bumped into him the other day at the airport, and I was like, hey man, we need to get you on. You and I were actually on the same plane together. It was either going to or coming from the class I was teaching with Marty. So it was pretty funny. So we tried to make sure we got him on. On Tuesday, we will have Dale Hunt. He will be coming on the show. He's been on the show a couple times before. He's going to be talking to us all about the USDA stuff, as well as a bunch of the other changing laws that are happening in the next, the next little bit here with cannabis. There's a lot of things that have changed since the last time he's been on the show. So we're going to get caught up to speed on what's going on in the legal world with cannabis. So that's going to be a lot of fun and really informative. And yeah, just looking forward to it. What's up with you, Roger?
Oh, not a whole lot. We're battening down we finally have winter for the first time in a while. We didn't have one last year, but just trying to protect all the plants that we have going. And I loved it. I thought I've been wanting to meet and talk with Harley Smith for a long time. We had a great little talk before the show and shared some info that was really cool. And yeah, he does. And Raw is his little program for you buying your own packages of individual minerals and the other products that he sells that go along with the old style, where he's embellished the hydroponic style with kind of a natural farming, or that kind of ideal. He's
Hybridize them, I think, is a better.
Yes, hybridize. That's good. Yeah, thank you very much, Steve. Yeah, so I think that was great. It was real nice to meet him after reading about him for 3 or 4 years. So that was really cool.
I've watched all of his videos. So
wow, what a wow.
He has a lot of cool short 60-second videos. Just cover one topic real quick. For those of you guys that haven't checked him out, definitely go check out his YouTube channel. NPK Industries, I think, is his YouTube channel. It's in the description. So yeah. So what else is new with you in your garden? Anything else going on? I know you've been quite busy with other stuff.
Well, we got a lot. I've got I got some personal things going on. My my lady, that is in the hospital, and she's been in the hospital for a while. So we're dealing with that. But we're doing hemp laws are changing. Yeah, I didn't want to have any personal thing, but man, you caught me off guard with that one for a minute. Hemp laws are changing, where we're not going to be grandfathered or umbrellaed under the current agreement that we had. So that's interesting that Dale's going to be on. I'm going to have to take a couple notes, and if I could get a couple questions in there to ask him. I've got some ideas about what's happened is, well, this would be a good thing for everybody to think about this week. We had a pretty open, which I felt like was probably too open, knowing the history of all the legalization and the way things have gone from state to state, partially from being on the show and partially from my background of being in the cannabis industry. I find that it's really weird that all of a sudden you don't think it's going to happen to you. But I actually didn't think that the hemp laws were going to stay the way they were in the Carolinas. And we kind of got hit with what they did in North Carolina, where they outlawed smokable hemp. Well, at least they're talking about, I don't think it's written in stone yet, but it looks like there will be no smokable hemp sales in any of the Carolinas come next year. Now, I think it's possible to export out of the state, but the thing is that most people were setting up for that. They also allowed the state law enforcement division to supersede on the writing of the bill in the Department of Agriculture. And being that it's an agricultural commodity, it really pisses me off that the state law enforcement division is superseding and having an impact and being able to, basically drastically modify and, ruin the hemp bill here in the Carolinas. So, yeah, I'm not on rant cycle yet because I had a lot going on. We're just thinking about that. We got until March. We're grandfathered till March, and then everybody for themselves. It's still going to work out. It's just one of those typical stumbling blocks you run across when you're in the cannabis industry, whether it be THC industry, edibles, hemp, or whatever you're trying to do. It's going to be one thing after another. They want to legalize it so that they can regulate it, and they can regulate you almost out of business to where they're almost regulating it to make sure there's still a black market so they can still fill their prisons. I don't know. I can't figure it out. Doesn't make common sense. We should all be free. We should all be free. So, yeah.
All right. And I've just been getting ready. I got some family stuff going on my own. My family members is going under the knife here next week, so that's gonna suck. And then just working on getting stuff ready for Zimbabwe, man. Getting ready to ship out. So just getting everything ready, getting equipment moved, getting equipment ordered, getting shit going. Got a lot of progress with that without saying too much, but yeah, we're really making leaps and bounds on that, and we'll be plants in the ground and probably before the first of the year, so it'll be fun.
I wish you all the luck. I hope you have good travels and it's all smooth. And are you getting there in the rainy season or the dry season?
Right now they're getting some rain right now, so we'll
see. When they get rain, they get rain. Yeah.
They had a tornado somewhere in South Africa the other day. People were freaking out about it. I guess it's really rare there. So, alrighty. Well, we'll wrap things up here. I need to get going. I need to actually jump back on and start working because my day is about to start. It is currently 6 a.m. Zimbabwe time, approaching 6 a.m. So my normal day is about to start. So I need to get going. But we'll catch you guys again soon, and we'll be back on Tuesday with Dale Hunt. And we're working on getting some other wonderful, awesome guests here in the future. We got a couple other people lined up. When somebody asked about Bob Hemphill, he will be joining us in the future. Just haven't had a chance to reschedule. And we have a couple other people that had to reschedule, or we had other scheduling conflicts, or this, that, and the other. We will get them back on. I also want to get Ed Rosenthal back on because his first interview we had so many mic issues, and I'd love to get Heavy Days back on and a couple of other people.
Oh, hell yeah.
So, we're working on that stuff. So, and then trying to figure out who else we want to get on. That would be really hard to get on a weird schedule because I will be on a weird ass schedule here before too long. So trying to just grab anybody else bigger that might be a little bit trickier to get on. on this continent before I peace out. So we will see what happens. So all right, you can catch me on Ponics YouTube channel, SoundCloud, iTunes, Spotify, all the places. Be sure to check out Chris Trump at naturalfarmingco.com. His wonderful website. You can also check out Harley Smith at NPK Universities and NPK Industries. You can also check out the description if you want more information on him. And what about you, Roger?
I love growingmarijuana.com, and you can check me on Instagram, Roger Latewood, on Instagram or Facebook at this point.
Awesome. And you can find Marty at AP Meds and Chris. Yeah, I think that's everybody. Chris Trump is also Soil Smith on Instagram. And
really?
His YouTube channel is Chris Trump. If you aren't familiar with Korean natural farming, go check it out. It is probably the best resource on the entire web. So
oh yeah. Awesome videos that teach you how to make all kinds of amendments that he makes and all that, yes, it's awesome.
Yep. So check that out, and we'll see you guys again on Tuesday with Dale Hunt. Cheers.